Okay, so we're going to talk a little bit about some of the reactions of esters. So I'm going to pick just a random ester and we're going to discuss the reactions. Okay, so first and foremost, you are going to have hydrolysis. So when it comes to the hydrolysis of esters, you are going to have something like this. So it's H2O and H3O plus. It's going to give you the carboxylic acid and the alcohol. So you just cleave the ester. You cleave the ester. Same thing happens if you add a base instead. Or you know what? Let me just, for the sake of uniformity, I'm going to. Yes. Okay. So H2O, NaOH. Now, when it comes to base catalyzed hydrolysis, you are going to have a carboxylate ion and the alcohol. Okay? Now, there are a few other reactions that we need to know. You have transesterification. Transesterification is quite simple. You just exchange the alcohol for another alcohol. It doesn't matter what type of alcohol it is. So you're going to have something that looks like this. You just connect the alcohol where it naturally was on the alcohol, and you just copy the same thing. Okay, and there will be an acid as a catalyst. So it's just like a successive esterification reaction. Now, you have a few other reactions. This one is quite easy. This is a reduction. So we've previously taken in organic chemistry the concept of oxidation. When it comes to oxidizing alcohols, you will oxidize a primary alcohol into an aldehyde and then the aldehyde into a carboxylic acid, or the secondary alcohol into a ketone. But no oxidation is possible for tertiary alcohols. The same thing applies here, but in reverse. Now we are reducing the ester. Okay? When reducing the ester, you are going to result in a primary alcohol. So what we do here is that we just isolate the carboxylic acid part. Okay? Like so. You just isolate it, and instead of having a double bond, you just put an OH. That's it. It's easy as that. Very, very, very simple. And now, we still have a reaction that involves converting the ester into an aldehyde. If you ever see this catalyst, your ester is going to convert into an aldehyde, just on the carboxylic acid part. So these two only involve the carboxylic acid part, nothing more. And we also have the amide formation. The amide formation is fairly easy. You just swap the alcohol for an amide. Remember, it can be primary, secondary, but never tertiary. So I'm just going to use NH3 here. It's going to be NH2. Okay, and of course, we're only talking about the major products of the esters. Okay, now we still have one reaction, which is whenever we have any radical that contains MgBr with acid. Let's say we have CH3 MgBr. Here we are going to produce a tertiary alcohol. Okay, so we are going to preserve the carboxylic acid part. We are going to preserve the carboxylic acid part, and we are going to, instead of having it as a carboxylic acid, it's going to be a tertiary alcohol, not a primary, so it's very close to this reaction right here. But it's a tertiary alcohol because we are going to have two CH3s here. Okay? Let's say if I change the CH3 into something else, let's say I might have written something as a skeletal formula, like so. It's going to look like this. So I just copy it. You're going to have something like this. and 2 here, of course. And that's it for the reactions of esters. They're very simple. I would say they're a bit simpler than the reactions of carboxylic acids. And that'll be it.